All right, so we've got a new set of guided notes. Let's just take a look at what they say and what exactly we're doing today. All right. All right, so in this section, we're still dealing with confidence intervals. It's called confidence intervals, right? And we're trying to answer a very different type of question than what we did before. Now I'm seeing two of my face up here. That's really interesting. That's a little bit better. Okay, so we're going to answer a different type of question. And before I even tell you what these questions look like, I'm going to explain a brand new type of distribution. Okay. Now, I think the only distribution that we have talked about in this class is the normal distribution. Remember, we call that the bell curve, like it looks like a bell. And what I have here is I have a graph that has a bunch of different graphs on top of each other. Okay. The one in black up top is the normal distribution. Okay, so this one up here is the bell curve. That's the one that we've talked about so far. So that one's the normal distribution. The dotted lines one, so like the three graphs that look like dotted lines, these are examples of the t distribution. Okay, now basically it looks like the normal distribution, but it's a little bit more smushed. Okay, so if I took the normal distribution and kind of smushed it down. Okay, and unlike the normal distribution, there's many different types of t distributions. Okay, and well, the type depends on this thing called the degree of freedom, which we'll talk about what that means a little bit later. Okay, and I'll show you a couple different graphs. Okay, the first one, like the more smushed one, like all the way at the bottom, this is a t distribution with 1 degree of freedom. So 1 degree of freedom. All right. The blue graph has 4 degrees of freedom, and the red graph here has 10 degrees of freedom. Okay, so it seems like as I'm increasing the degrees of freedom, and it looks like the graph is getting higher, and it's also looking closer and closer like the normal distribution, right? What the t distribution is it basically is this distribution that is really smushed, but as you increase the degrees of freedom, it gets closer and closer like the normal distribution. Okay, so it kind of looks like the bell curve, but not really. All right, something about the t distribution. I don't know if you've heard of the beer company Guinness, but some guy working for Guinness made this distribution and gave rise to this new type of question or new process on how to answer this. So next time you think about, I'm not going to say next time you drink Guinness, but next time you think about it, you can think about statistics. All right. Now, all I'm going to tell you about degrees of freedom is, let's say that n is our sample size, right? N is the number of things that we have. I'm going to give you the easiest formula in this class. The number of degrees of freedom is n minus 1. Okay. The easiest formula in this class is the number of degrees of freedom we have, literally the sample size and subtract 1. Okay. I have some properties of this new distribution called the t distribution. It's symmetric, right? It looks like if you cut in half, it would be the same on both sides. It's unimodal, so it has one mode or one peak, right? It's more spread out than the standard distribution. Like you can kind of see that it's like shorter. And as you increase the degrees of freedom, the more normal it looks, right? So it looks like the normal distribution. All right. So next what we're going to do is we're going to compare what we did in the last section to what we're going to do in this section. Okay. Now you're probably looking at the top of this chart and being like, what is section 8.1 and 8.2? These are the sections that I use in my Math 155 class, and I forgot to change it for this class. So we're just going to change it real quick. This is the last section. And the right side of the graph is this section. Okay, so you don't have to think about the numbers or whatever. So what we're going to do real quick is we're just going to kind of review what we did in the last section, and then we're going to compare it to what we're going to do in this section. Okay, so let's just start with the questions that were given. Okay, last section, we were given questions that gave us a lot of different variables, kind of like on our quiz. We were given sigma. What does sigma stand for? And what type of standard deviation? Population standard deviation. Population standard deviation. Okay. Questions also gave us X bar. What does X bar stand for? Sample. Good. We were also given, looks like we're given N here, right? What does N stand for? Sample size, good. And we were also given like this percentage, like 95%, 80%. Does anyone remember what that's called? The confidence, not interval, but oh, the first word is right. Confidence level. Confidence level. Good. Confidence level. Okay. So this is basically all we were given. And what we were asked to do is it said like, what's the population mean, right? We wanted to say that we were blank % confident that the population mean is between these two numbers. Okay, so we did all this stuff to get the population mean. Okay, now how did we do this? First, we found the critical values. We did that by using the chart, right? So we looked in the chart, found the critical values. And what I didn't tell you about that chart is there's a very specific distribution that was used to create that chart, and it was the normal distribution. Okay, so you don't have to know this, but the normal distribution makes that chart that you had to look the critical values up in. Okay, I am going to say we're going to use the small chart. Okay, and you'll see why I'm saying this a little bit later. Okay, so it was a pretty small chart that we used. All right, once we found the critical values, we found the standard error. Does anyone remember the formula for standard error? Perfect. Sigma over the square root of n. All right, and then after we did that, we found the margin of error, which is actually written up here, right? We take our critical value and we multiply it by the margin of error. Oh, nope, we don't multiply it by the margin. What do we multiply it by? The standard errors. Oh my goodness. I am not used to teaching at this time. All right, let's just say I did that on purpose. Okay, so this pretty much covers everything we did in the last section. Of course, there's like the conclusion and all that stuff, but this pretty much summarizes everything that we did last class. Okay, let's talk about what we're going to do in this section. Okay, in this section, we're going to be given a problem, and it's going to give us a bunch of stuff. So let me show you what we're going to be given. Okay, now you might want to leave a little bit of space up top just to write something above it, but we are given the sample mean, so I'm going to leave a little space. That wasn't enough space, like that. That's the sample mean. We're going to be given the sample size n, and we're going to be given the confidence level. Okay, but instead of the population standard deviation, guess what we're going to be given? Sample standard deviation. What's the symbol for sample standard deviation? S. S, right? That's our easy symbol. This is the sample standard deviation. Okay, we're still going to be asked to find the population mean. Okay, so the question is very similar. We're literally just given the sample standard deviation instead of the population standard deviation. That's the only difference between these two types of questions. The process is a little bit different. Okay, so we're going to estimate the mean by first finding our critical values. We're not going to use the normal distribution anymore. What distribution do you think we're going to use? T-distribution, right? That's why I introduced this distribution up here. There's only two distributions we know. Instead of using the normal, we're going to use the T-distribution. Okay. Now, you're not actually going to have to use the graph of it or whatever, but we're going to use a chart for this. And instead of the small chart, we're going to use the big chart. You might be like, okay, what's the big chart? Well, if you flip to the back page of the notes here, you'll see the big chart. This is the see a lot of I feel like it looks really scary, and it does look scary. I promise you it's not that bad. Once we learn how to do it, it's going to be very simple. You'll be like, okay, it's not that bad. All right. I do like scaring everyone about it, though. I think it makes everyone. I should have done this before. I like looking at everyone's face when they see the big chart the first time. They're like, whoa, what do I do here? Oh, well, we'll figure out how to use it. It's not that bad. All right. Next, we're going to use the standard error. Okay, but the standard error formula has the population standard deviation in it. What do you think the standard error formula for these questions are going to be? Yeah, it's literally, instead of using the population standard deviation, we're going to use the sample standard deviation, S over the square root of it. So even though it's a different formula, it's the same formula, it's just a different symbol for standard deviation, okay? So still standard deviation over the square root of it. When we find the margin of error, it's still the critical value times the standard error. Okay, so it's still the same thing. Everything's the same except we're using S instead of sigma, and we're using the big chart instead of small chart. That's all the difference. All right, let's flip to the next page. And I think the big question for you guys is, how do we use this big chart, right? We have this big chart, it looks scary. What do we do to find critical values? Okay, I have a kind of 3-step process on finding critical values. First, we're going to find the degrees of freedom. What's the formula for degrees of freedom? N-1, right? That's our easy formula to figure this out. Okay, the number of degrees of freedom is going to be the row that you use. Okay, so you're going to have a bunch of rows. They're going to be labeled by the degrees of freedom. That's the row you're going to look at. The column that you're going to look at, well, we'll talk about that when we do an example. Okay. By the way, I am very bad at quickly telling the difference between rows and columns. So if I say column and I meant row, I'm very sorry. I just, for some reason, it doesn't work out for me. I don't know why. All right. Let's do this example. We have a simple random sample of size 10, and it's drawn from a normal population. Okay. We want to find a critical value for a 95% confidence interval. Well, maybe we should find the degrees of freedom first, right? What should I subtract to get the degrees of freedom? 10 minus 1, right? That's our easy formula. We should get 9. Okay. So in our chart, we're going to look at the row that's labeled 9. Okay. So let me just go back to this chart real quick. Okay, we have this row on the very left, and it says degrees of freedom, and we have 9. Okay, so we're definitely looking at this row that says 9. Okay. Now the big question is, okay, what in the world are the columns labeled as, right? There's this thing that says area in the right tail and all this weird stuff written up. We're going to ignore that because I'm going to tell you something funny. When I first taught this class, I didn't realize that there was a cheat. So I told people to do this weird thing to find the area in the right tail, and it was crazy. There's a cheat way to do it. Go to the very last page. On the very bottom, it says confidence level, and there's a bunch of different percentages here, right? So since we're dealing with a 95% confidence level, I'm going to look at the column that is the 95th percentage column. It looks like it's the 1, 2, 3, 4, 5th column. So when I go back here, I'm going to count 1, 2, 3, 4, 5. That column is the degrees of freedom, or is the critical value that I want. Okay, does that kind of make sense? Yeah, right. So it's not that bad, right? You're just looking at the row for degrees of freedom, and it's the confidence level that's labeled. Okay, so 2.262. Let me go back here. 2.262 is my critical value. All right, any questions on example? The chart isn't that bad, I promise. All right, I'm going to give you like 1 minute to try example 2, just so you're thinking about the chart, and we'll come back in a tiny bit. All right, I think everyone is finishing up here. What was the number of degrees of freedom for this question? Oh, before that, the row. 14, good. Getting ahead of me there. All right. No, okay. So we go to row number 14, and we're like, all right, it's right here. And then I know it's the front page. If you are doing the homework, by the way, you might just want to cross out the top part and just label it with the column labels on the bottom, so you don't have to flip back and forth. But in case you didn't do that, you can go back and be like, okay, 98 is the 1, 2, 3, 4, 5, 6 column. So I'm gonna go 1, 2, 3, 4, 5, 6. Looks like 2.264 is my critical value. So going back here, it looks like 2.624. That's my critical value. All right. Any questions on example 2? All right. Now, if you take a closer look at the chart, you'll see that, okay, the degrees of freedom go from 1, 2, 3, 4, all the way up to maybe 40, right? Once we hit 40, we don't have 41, we jump to 50. And then at 50, we jump to 60. And then at 60, we jump all the way to 80. And then 80 goes to 100, and 100 goes all the way up to 200, okay? So you're probably wondering, okay, what do I do if I have like 82 degrees of freedom, right? There's no value, there's no row to look at, okay? The convention that most statisticians use is if it's not on the chart, we're gonna go to the smaller one before it, okay? So for example, if I had, I don't know, 73 degrees of freedom, we would go to row 60, okay? So we go to the smaller one on the chart that's there, okay? Now you're probably like, okay, what happens if I have something bigger than 200? I will give you something bigger than 200, so you don't have to worry about it. Okay, so we're gonna look for this next smaller one. If that doesn't make sense, let's just do example 3 and see what happens. Here we have a simple random sample of size 58. So how many degrees of freedom do I have? 57, perfect, okay. Looking at your chart, what row am I gonna use? Row 50, right? Now there's no row for like 57, so you're gonna look at the smaller one before it, okay? So since the only row that's smaller than 57 is 50, looks like we're gonna use row 50. Okay, so going back to my chart, I don't like switching back and forth. We're gonna take a look at this row, and then the column we're gonna use is the 99. So it looks like my critical value is 2.678 here. Okay, so we're gonna use 2.678. All right, let's do that. 2.678. All right, does that make sense? All right, let me have you try example 4. And if that doesn't make sense, then I think we'll clear up if we go through this one. Right, how many degrees of freedom do we have? 91, good. So looking at our chart, we're just gonna go and search for the row for 91. Oh, it's not there. What row are we gonna use this time? Row 80, right? We go to the smaller one. So I'm gonna look at row 80. I wanna do what percent was it? 50, all right, so you're gonna look at 50, and it looks like our critical value is 0.678. Okay, so all the way back here, 0.678 is my critical value, okay, because we use row 80. All right. Any questions on using the big chart? All right, it's really not that bad. I know it looks scary, but it's almost as easy as using the small chart. You just have to find the row, right? All right, let's put this together and then I'll let you go. So for these things, Ariel asked a really good question. Do we use the same assumptions? The answer is yes, okay. One of the assumptions is slightly different, right? The last section asked you to see if sigma was given. Here, we're wondering if S is given because that's what we're looking for if we can do this process, right? So instead of sigma, we're looking for S. We're also going to ask ourselves, is the sample size large enough? So is N bigger than 30? Or is the population approximately normal? So same sort of assumption going on here, okay? Now, let's take a look at this procedure here. The first thing we're going to do, check our assumptions, right? So is S given to us? Is the population big enough or is the population normal? Step number 2, I want you to cross out, okay? So I made this a year ago, and there was a question on the online homework that I gave my Math 155 students that told them to like calculate the sample mean and also calculate the sample standard deviation. But honestly, that's just a lot of work, and I don't know, it's slightly confusing. So we're just going to cross that out. Okay. All right, step number 3, you're going to find the number of degrees of freedom by taking our sample size and subtracting off 1. You're also going to use the chart to find the critical value. Step 4, you're going to find the standard error, right? So you're going to use our formula S over the square root of n, find the standard error. Step number 5, find the margin of error, doing critical value times the standard error. Step 6, you're going to do your interval just by taking your sample mean, add the margin of error, subtract the margin of error. You don't have to write it in that form if you don't want to. Okay, so I know that form is there. If you want to use the parentheses form, that's fine. And then step 7, the interpretation is literally the same. So we are blank % confident that the mean is between these two numbers. That always stays the same. All right.
Are we crossing that out?
Yeah.
Oh.
Yeah, you don't have to write it in the form. If you want to, that's fine, but I gave you another form to write your answer in. So, yeah. All right, let's do, what we're gonna do is we're just gonna write down the information for the next question, then I'll let you go. Because I actually meant for us to spend more time on this one. Okay, so we have a food chemist. Food chemist is analyzing the calorie content for a popular type of cookie, okay? They took a sample of 8 cookies. The sample had a mean of 1.15, whatever, and a standard deviation of 2.8. We want to find a 98% confidence in. Okay, here I'm not giving you a lot of symbols, so let's figure out what they mean and let's write down everything that we're given. Okay, we're already told that n equals 8, so we don't have to think about that. We know that the mean is 115.375. Is that the sample mean or the population mean? Sample mean, right? It says the sample had a mean. That's got to be the sample mean, right? The harder one to figure out is, okay, we have 2.825. Is that the sample standard deviation or the population standard deviation? And why do you say sample?
That's the beginning of the sentence that mentioned the standard deviations as sample.
Yeah, right. It's literally in the same sentence as like when we introduce the sample. It's not saying based on previous studies, the sample standard or the standard deviation is this, right? It's literally in the same sentence as the sample. So because of that, I know this is the sample standard deviation. So what symbol is this going to have? S, good. All right, we want to find a 98% confidence interval for the mean number of calories. All right. Any questions on writing down our information here? All right, this is where I left off my last class, so I think I'm going to let you out a little bit early.